Hi everyone, welcome to the session. So again, we are going to continue this wireless session where we just have to understand a little bit more about this, how the wireless is going to be connected to the network, how the AP is going to come in a picture. So more about the architecture point of view, because we are just dealing with the CCNA level of the wireless understanding. Still, we are doing that very brief to deeper side. So at least you guys having the good understanding about this wireless concept, right? So what is the objective of this particular module? So in this module, we are trying to understand how the AP is going to be connected, how WLC can be accessible, how the Cisco WLT is going to connect to the network, how the configuration is going to look like for the WLAN, that is a wireless LAN. So these all concept we just have to understand. Before I start this session, I have to just show you something. Let me show you. So if I just go here and type the Cisco WLC and I just go on the images, you'll find that this is the WLC, right? And in this WLC, you'll find the multiple ports are there, right? So you just have to good understanding why we have these all ports, right? We having some LED, we have the console port, we have some this kind of the LAN ports, PoE port, and there are two special port also. So we just have to understand different ports available on this particular Cisco WLC, right? Even you open this one, so this one also you're going to find the different ports are there. So if I just going to zoom, you can see there are some kind of the, let me show you. So still not much clear, but you can see there are some LAN ports. These are some kind of the special ports. These are the console port might be somewhere written here, but it's not visible. So you are going to get different ports where something is going to be written. So you should know about why these ports are very special and what is the purpose to use these all ports, right? So if I go in the PPT, you see this is a diagram. So comparing the connections to the autonomous and lightweight AP. So as I already explained, whenever we have the lightweight APs, we require the WLC. But whenever we have the autonomous AP, we not require the WLC. That is autonomous is standalone APs. Means the AP having the capability to the switching plus control connections. Means data switching plus control connection. However, when the AP is the lightweight AP, they can do the local switching, that means they can still going to do the data exchange locally, but when they want to take the some decision, they have to reach to the brain, which is the WLC. So brain is there. So some scenario, if we are going to use the local mode of the AP deployment, that's lightweight AP. So my control connection data both are going to WLC, and then it is going to back to the client or any other AP where the client is connected. But if I'm going to use the flex connect mode, then my data is going to be locally switched and my control is going to be WLC. So this is the key difference between the autonomous system AP and the lightweight AP. Okay. Now, if you see these devices are going to connect with the trunk port, might be the access port also. So if you find if my AP is going to connect with the trunk port, right? So you probably seen this is the autonomous AP, right? Multiple SSID is going to broadcast. Even for the lightweight AP also, you're going to find the trunk port AP is going to be configured. Some scenario single VLANs acting as SSID, or this just broadcasting the SSID, then we can use the access port as well. So it totally depend like your deployment method of how you are going to deploy the wireless system. And again, these devices are going to build the CAPAP tunnel between these two devices, and they're going to get all exchange communication, control communication via the secure method, right? So whenever we have the WLC, we just have to use the the wireless controller WLC. You are going to get this kind of dashboard login page, right? So once you get the login page, probably let me show you. So you just have to put username and password, and then you're going to get this kind of the page. Let me show you. This page is going to be visible to you. Let me see. I don't know why it is not opening, but let me try it again. For some reason it's not working, but let me try different articles. So in this article, if you see that they are different WLC, and if once you're going to log into WLC and you just put the IP address, and then you're going to get this kind of the page, right? And in this page, you are going to get a lot of information, right? You can see we have the monitor tabs. So this is actual WLC, how the look and feel is going to WLAN, right? Wireless LAN, controller information, wireless connectivity, security management, commands. You can do some ping, testing, help, feedback. And here you can see summary, how many access point connected with Cisco Clean Air, static. This means you can see how data is flowing through this WLC, CDP neighbor you can see, rogue AP you can see, client multicast application, and which band it is working, what is the management IP of this particular AP, software version you can see that, and since when this AP, this WLC is up and working, system name, what is WLC name, you can see, do you have any redundancy of this WLC? Redundancy means, let's suppose I have the 50 AP and they are going to connect with one WLC, but what if that WLC is going to be down? Do you have any redundancy? You can just think about this way. In my office, I have the multiple like AP, and this is my single WLC, right? This is my WLC. Let me write correctly. So this is my WLC, and this WLC connected to the multiple APs, right? So these all are forming the cap web tunnel, but some region this WLC went down. Then what is going to happen? These all are stop doing the communication if they are going to work in the local mode. Even they're going to work in the flex mode, but the new control information they are not going to get. So we require the redundant WLC. So in case if this WLC is going down, they are going to form the another cap web tunnel, and it is going to keep serving the same what primary WLC was serving. So that's why the redundancy is going to be required here, and it's going to play a very vital role in terms of the failover scenario. Right, other you can information seek like what type of the standard they are using, what is the internal temperature of the device. You can see how many guest Wi-Fi users clients are connected, what is the different SSID clients are connected, CPU usage you can see that, memory usage you can see that, some most recent trap logs you can see that. So these kind of the information you are going to get once you log into the WLC. Even access point are connected with the which radio frequency, means the frequency Ethernet wireless WLAN standard. You can see 802.11.AN, BGN, and total number of how many APs are up connected, how many up. These all are information they are showing that. So this is the same thing they are talking. Once you have the access in CCNA, you don't have to worry about that access part because it's a part of the further course. But you have a little bit an idea how this is going to look like. So you just have to log in this wireless controller. You just require username password. Likewise, you accessing other devices. Once you put that, you are going to get this kind of dashboard which I was showing earlier. This kind of dashboard, and in dashboard you are going to get this kind of information. You can see the same thing I was showing that, like what are the devices connected, what is the WLAN, what is the controllers, everything information is going to be shown there, and based on that probably you can do a lot of other things. So when you're using the port of WLC, which I was explaining beginning of the presentation, I show the WLC having the multiple ports. I can open this one, see these WLC have multiple ports. So what are the role of these ports? So you can see you can connect the several different type of the controller ports to your network. Service port, so there is a one service port. So this service port is going to use for the OOB, out of band management. What is out of band management? So let's say suppose in your network you have some devices connected, right? And this, think about this is WLC. This WLC is connected, and you are accessing this WLC with the management IP address through your LAN network or over the WAN network, right? But let's suppose somehow you lost this connectivity LAN or WAN network for some reason, then how you are going to access this WLC? That's a special port is going to required, which is going to connect the out of band management connectivity. That is a third party connection. Might be using some kind of the ISP, like the 4G link or 5G link, right? And those link are basically just using in case of a disaster is going to be happen when you lost your internal network connectivity, including the LAN and WAN. Then still you need to access the device, right? Why I lost the connectivity, what is happening in device is up or down, or might be you for some reason this device having some abnormal behavior, then you want to do the troubleshooting. So you require the out of band. So this can be only possible if you're going to use the service port configuration. So this service port is used for the out of band management, and that can be used for system recovery. Initial boot up function always connect to the switch port at the access mode. So whenever you configure the service port, it is always going to be access port, not trunk port. The single VLAN is going to be propagated on this particular port. Distribution system port used for the all normal AP and management traffic, usually connect to the switch port. That is a trunk mode. Means if you want to connect the different APs on the port, right, on the WLC, so you can use this distribution system port. So there might be some kind of the nomenclature you are going to find. It is not visible here. Might be this port, these ports are going to be used here, which is going to be connected to the switch, and then you can just use this for the any kind of the AP and trunk port connectivity with the switch. There is a console port. Console port is something, let's suppose you want to configure locally to the WLC. You know, you take the console of the router, you take the console of the switches, right? Similarly, you can take the console of the WLC. So console means you just use the console cable, right? And after using the console cable, you use your putty, or might be you are going to use secure CRT. These are the tools. By using these tools, you connect a laptop with the console cable with the WLC, and you're going to configure initial configuration, local configuration. You want to do that local troubleshooting, so you can do at the console port. So again, it is acting as a out of band management, but it is just system like recovery initial boot, similar to the out of band management. Out of band also is going to be console connection, but this is going to happen by the remotely, and this console is going to happen by the locally. Since you have to present in front of the device with the laptop and console cable, then only you are going to get these informations, right? So whenever you're going to configure this console port, you have to make sure like out of band management, system recovery, initial boots functions, asynchronous connection, terminal emulator, that is going to be set on the 9600 baud 8-bit data, right, and one stop bit by default. So this setting you just have to use while setting the console port by selecting the COM port and all. So these are the 3 ports that is going to use. The last but not least is the redundancy port that I was talking about, the HA port. So here you can see in this I was talking about this port redundancy mode. So when you want to enable this redundancy mode, means you having the requirement to WLC need to be work in the redundancy mode, right? So WLC1 and WLC2. So these are must be going to connected with the HA port, that is known as the redundancy port. So these are going to be connected, and by doing this, if it is going to fail, the first WLC is going to fail, client and AP are going to move to the second WLC. So this is the beauty of the redundancy mode. So this redundancy mode is very useful, and it is like real-time requirement whenever you want to deploy the WLC in your network. So redundancy port used to connect the peer controller with the high availability, right? So just you want to connect the another controller, you can use the redundancy. So you can see these are like the setup Cisco wireless LAN connection controller ports. So you can connect this switches by using the link aggregation. By service port you can just connect for the out of band management. Console port you can connect for the local connections, right? And these are going to form the cap-up tunnel over the physical connection which is going to form between the WLC and the switches. So you rarely going to find the AP directly going to connect the WLC. Logically they are going to connect, but physically it always separated by the switches. So in WLC and the AP, you must going to find there are switches. So these switches are basically going to be core switch, access switch, distribution switch. It's totally depending on your infrastructure, but WLC having a limited port. So WLC basically connect with the switches, and switches further connect with the multiple AP. Let's suppose you're having 100 APs, but WLC doesn't have that much port. So you just have to use the switch, might be 24 port switch into a stack of the 5. So they are going to give you the 24 into 5, you can just multiply around more than 100. So they are going to be useful to just serve the APs, and that switches are must be going to connect to WLC, and then they are going to logically form the cap-up tunnel with the WLC. So you can see here other ports information also we have. So in WLC we have some management port, redundancy management port, virtual interface, Service port, we just use that dynamic interface. So let me explain one by one. So management interface used for the normal management traffic. So let's suppose I have the management interface on the, like you can see even the IP would be there on the particular WLC. So see, this is the management IP. So this management IP you define, it is a part of the management interface. So why this IP and interface is going to be required? Just you want to take remote access via the TACAX, via the radius, user authentication, WLC communication, web-based access means you have to take the GUI access, CLI access, GUI access, SNMP network, traffic, network time protocol, syslog. These all are going to be like basically talk with the help of the management interface, right? And also management interface can use to terminate the CAPAP tunnel between the controller and AP. So if having the multiple controller, they have to form the CAPAP tunnel, and AP also need to form the CAPAP tunnel. So one end is the AP IP address, another end is the WLC IP, which is the management interface IP address, which is going to use to just terminate the connections. Okay. So this is about the management interface. Similarly, we discuss about redundancy management. So like redundancy interface is something different, but redundancy management is something different. So in case of the primary management interface is going to be down, same function is going to do what management interface is going to do, but it's a redundancy management. The management IP address, redundant WLC, is a part of the high availability pair of the controller. The device, active device WLC use the management interface address, while the standby use the redundancy management address. So if I have the two WLC, one act as a primary management, another act as a secondary management. So in case of the failure of the primary WLC, you just have to use the secondary WLC management IP address. You just have the access and you can just do the troubleshooting, whatever you want to do that, right? Virtual interface also we have, right? So IP address with the wireless client when the controller relying the DHCP request, performing the client web authentication, supporting the client mobility, that it is going to be required. So it is basically the IP address facing the wireless client when the controller is relying on the client DHCP request. So when we have the DHCP requirement where the IP is going to get from DHCP, performing the client web authentication and the supporting the client mobility, then virtual interface are going to play a very vital role, right? And service port interface, bound the services port, use the out of band management. We discuss about dynamic interface, just use to connect the WLAN and VLAN. So these are going to be frequently we are going to get in the configuration of this WLC. So you should know about this different port type and what is the meaning is going to happen. And you can see here different VLANs we have, WLAN, SSIDs, dynamic interface for the different VLANs, switch connected WLC and WLC connected to the AP, but this should be the reverse. Physically always AP connect with the switches. Very rare you are going to find the AP is directly connected to WLC, right, in a standard design. So logically they are always going to be separated by the switch, and you can see this might be the CAPAP tunnel, but in between we have the switch between these two AP and WLC, and they are going to broadcast that like SSID. SSID is just a network. You can see these are the names of the SSID. So this kind of name is going to be broadcasted, and any client going to be connect with these names. So further we are going to see this radius configuration where you can configure the radius and TACAX. You can see there the radius server. If you want to configure a new radius server, you can just use this radius server configuration. Let me show a little bit bigger. It's showing something different. So here you can see this is the radius server configuration, and the other radius server are having different IPs, password that you are going to get, and this is the interface. You want to create any new interface, virtual interface, management interface, you can create from there, right? And let me a little bit zoom in so you guys can understand. So you can see this, if you want to create the different interface name and you want to tag with the VLAN ID, dynamic interface, to just propagate the SSID, you can use that also. Here you can configure the virtual identifier like the VLAN, and you want to assign the IP address and gateway, you can do that, right? And you can see here we have some kind of the WLAN detail. So these WLAN detail is just SSIDs. You just have to create a new SSID. That SSID is going to be show here. You just have to put the name, what is a SSID name, and this is going to broadcast to the AP, and AP is going to further broadcast to the client, and client are going to connect. So whatever the name you are going to put here, this name is AP is going to broadcast, and you have to click on these names and you have to connect this, and it is going to ask the password. And this is, you can see further, you have this kind of the general configuration. You can see these are the security. We discuss about WPA, right? WPA1, WPA2, WPA3. We discuss about 802.1x in the previous section. We discuss about the VIP WPA, right? So these authentication security also we have to configure, because it's a very useful. If you do the open authentication, it is going to create a problem, but there could be the open authentication with the security, where we can redirect the authentication portal by the OTP, like by given the example for the airport and the public transport or metro, like that. You can just refer about that. And here you can do the security settings, whatever the security you want to enable. You see these all options are available, like WPA 1, 2, 3, which you want to enable, TKIP, CCNP, GCNP. See, these all 128, 256, these all options are showing here. We discuss in the security chapter. And similarly, you can see here we have the little bit more information, right, about the radius server, triple attack server, whatever we have. This is also going to be required to just make the real-time authentication for the clients, for the devices as well. So you can see these are going to work in different ports. You just have to configure. So configuration part is not of the syllabus. So at least you should know basic idea, because how it is going to look like, what the configuration is. So whenever you get a chance, you can just scroll. You can see that WLAN detail, SSI detail, how we can see that, and how the management via the interface is going to be happen. So this is something about the wireless, and we discussed a lot of things about the wireless. We discussed about the how the wireless is going to be built, how the security of the wireless is going to be implemented, how the Cisco wireless architecture is going to look like, what is the fundamental of the wireless network. So these all 4 topics we cover, which is going to be required in the CCNA, right? 200/301. So in further, we'll discuss more about the next chapter about in CCNA syllabus, and we'll see how it is going to be help to the learner. All right. So thank you so much for watching, and see you in the next chapter. Have a great day. Bye bye.